The morning of February 14, 1943, Washington, D.C. A stack of intelligence reports arrived on the desk of Admiral Land, chairman of the United States Maritime Commission. Among the classified documents was a decoded German military communication, intercepted 3 days earlier from Kriegsmarine headquarters in Berlin. The message, stamped with the highest security classification, contained an economic assessment prepared by German naval economists for Grand Admiral Karl Dönitz. Their conclusion was stark, almost dismissive. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. American claims of merchant ship production were statistically impossible propaganda. No industrial economy, the German analysts insisted, could sustain the reported output levels. The mathematics simply didn't work. Admiral Land read the assessment twice. Then he picked up his telephone and placed a call to the Richmond shipyards in California, where Henry J. Kaiser's operation had just launched 3 Liberty ships in a single day. The German economists weren't wrong about the mathematics of traditional shipbuilding. They were wrong about what America had become. This is the documented story of how American industrial capacity during World War II didn't just surprise German military planners, it fundamentally violated every assumption they held about economic production. Based on declassified intelligence assessments, Maritime Commission records, and verified production statistics, this is the account of the moment when German economic analysis collided with American industrial reality. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. September 3rd, 1939. Germany invaded Poland 2 days earlier. Britain and France declared war on Germany. Grand Admiral Karl Dönitz, commander of Germany's U-boat fleet, understood immediately that the coming conflict would be decided not by battlefield heroics, but by tonnage mathematics. His calculation was elegant in its brutality. Germany needed to sink Allied merchant ships faster than Britain could replace them. According to his calculations, a fleet of 300 medium Type 7 U-boats could sink 1 million tons of ships a month and within a year sink enough of the about 3,000 British merchant ships, comprising 17.5 million tons, to strangle the British economy. The problem was that Dönitz didn't have 300 U-boats. When war began, he commanded fewer than 60 operational submarines, but his fundamental premise remained sound. This would be a war of production versus destruction, of shipyards versus torpedoes, of industrial capacity versus military strategy. In 1939, the United States Merchant Marine ranked 18th in the world by production capacity, just behind Romania. American shipyards, decimated by 2 decades of economic depression, produced virtually no commercial shipping. The industry employed roughly 100,000 workers scattered across a handful of aging facilities. Most American shipyards hadn't built an ocean-going vessel since the end of the First World War. The infrastructure had atrophied, the workforce had dispersed, the techniques had stagnated. British intelligence understood the arithmetic of survival. In the fall of 1940, with German U-boats sinking merchant ships faster than British yards could replace them, Sir Arthur Salter led the British merchant shipping mission to North America. Their request was desperate. Could American shipyards help build the vessels Britain needed to survive? The answer, based on existing American shipbuilding capacity, should have been no. American yards were already occupied with naval construction. There was no excess capacity. There were no experienced workers available in sufficient numbers. There was no infrastructure to support emergency expansion. But the answer wasn't no. The answer was Henry J. Kaiser. Kaiser had never built a ship in his life. He was a construction engineer who had worked on massive public projects, the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam. He understood concrete and steel, schedules and logistics, but he knew nothing about traditional shipbuilding. That ignorance would prove to be his greatest asset. When Kaiser looked at ship construction, he didn't see centuries of naval tradition. He saw an assembly problem that could be solved with modern industrial techniques. The British design that formed the basis for what would become the Liberty ship was simple: a basic cargo vessel based on a 1939 tramp steamer design. The design was adopted by the United States for its simple, low-cost construction. These ships were built as quickly and cheaply as possible, with a programmed obsolescence of just 5 years. They weren't elegant, they weren't fast. Franklin Roosevelt himself called them ugly ducklings. But they could be built quickly, and they could carry cargo. The first Liberty ship, the SS Patrick Henry, was launched on September 27, 1941. The first ship took about 250 days to build. By traditional shipbuilding standards, that was actually quite fast. But Kaiser wasn't interested in traditional standards. He was interested in revolution. The key was welding. Traditional shipbuilding relied on riveting steel plates overlapped and fastened with rivets driven by skilled workers. It was time-consuming, labor-intensive, and required years of training to master. Welding could be done much faster than riveting, and in some cases could be done automatically by machines which were even faster. And welders could be trained quickly. A complete novice could be trained to be a productive welder doing the simplest tasks in little more than a week. Kaiser took this further with prefabrication. Rather than building ships, piece by piece on the ways, his yards constructed entire sections in different facilities. The 250,000 parts were prefabricated throughout the country in 250-ton sections and welded together. A bow unit built in one location, a stern frame in another, complete deck houses assembled elsewhere, all converging on the shipway for final assembly. This wasn't shipbuilding as the world understood it. This was industrial mass production applied to floating steel structures, and it terrified German military planners who learned of it through intelligence reports. The German Naval Intelligence Service, the Marinenachrichtendienst, maintained an extensive network of operatives tasked with monitoring Allied industrial capacity. The department focused its efforts on France, the United States, and above all the United Kingdom. These operatives filed regular reports on Allied shipbuilding, compiled production statistics, and attempted to forecast future capacity. But the numbers coming out of America in 1942 and 1943 made no sense within German economic frameworks. German economic planning operated on fundamentally different assumptions. German industry had developed through careful, methodical expansion over generations. Quality was paramount. Each shipyard maintained its own specialized workforce, its own proprietary techniques, its own standards. German yards built excellent ships, well-designed, carefully constructed, built to last decades, but they built them slowly, in small numbers, by highly trained specialists. The reports from America described something else entirely. Shipyards that hadn't existed 6 months earlier, workers with no previous shipbuilding experience, construction times that seemed to defy physics, and production numbers that suggested either massive Allied propaganda or a fundamental transformation of industrial capability. In December 1941, Japanese forces attacked Pearl Harbor. Germany declared war on the United States 4 days later. This decision, made by Hitler against the advice of his naval commanders, transformed the Battle of the Atlantic from a contest between Germany and Britain into a conflict between German submarines and American industrial capacity. Dönitz recognized the danger immediately. In 1942, when the United States entered the war with its enormous shipbuilding capacity, the change thus brought about necessitated a further adjustment in the methods adopted by the U-boats. The 1942 German strategy shifted from simply sinking British shipping to preventing American ships from being crewed and manned. If Germany couldn't build ships faster than America, perhaps they could sink ships faster than America could crew them. The mathematics seemed to favor Germany. In the first 6 months of 1942, U-boats sank over 3 million tons of Allied shipping. The Allies lost 1,664 ships in 1942, and 80% were destroyed by submarines. These were devastating losses. If sustained, they would cripple Allied logistics before American industrial production could even matter. But American production wasn't ramping up gradually, it was exploding. In total, this increase raised the planned output of all merchant shipbuilders to about 500 ships, 5 million total deadweight tons for 1942, and 700 ships, 7 million tons in 1943. The emergency shipbuilding program wasn't just expanding existing capacity, it was creating entirely new shipyards, training entirely new workforces, implementing entirely new production methods. By mid-1942, the competition between shipyards had become almost theatrical. Oregon shipyards and Richmond shipyards in California engaged in what the Maritime Commission called stunt ship demonstrations. In August of 1942, Oregon broke records by launching a Liberty ship in just 23 days. Bedford's Richmond yards responded by launching one in just 21 days, which drove Oregon to complete one in just 13 days. Not to be outdone, the Richmond yards shot back by completing a Liberty ship in just 7 days. The SS Robert E. Peary represented the ultimate achievement. Built by the Kaiser Permanente Metals Corporation's yard in Richmond, California, launched just 4 days, 15 hours, and 30 minutes after the keel was laid. 4.5 days. From keel laying to launch. This wasn't a stunt that required special conditions or preparation. It demonstrated what the streamlined, prefabricated, mass production system could achieve when pushed to its limits. German intelligence officers reading these reports in Berlin faced a choice: believe the numbers were propaganda, or accept that America had achieved something unprecedented in industrial history. The skepticism was understandable. Traditional German shipbuilding, even under wartime pressure, required months per vessel. The Kriegsmarine's own yards, despite Albert Speer's later attempts at rationalization and mass production, could not approach American production rates. Speer and his hand-picked director of submarine construction, Otto Merker, believed that the shipbuilding industry was being held back by outdated methods, but even their revolutionary approaches couldn't match what was happening across the Atlantic. German economists applied their standard analytical frameworks to American production claims. They calculated required steel tonnage. They estimated necessary workforce size. They computed welding rod consumption, electricity usage, transportation logistics. By every conventional metric, the reported American numbers were impossible. The steel alone to produce the claimed volume of shipping would consume more American steel production than seemed available. The workforce required would number in the hundreds of thousands, all trained in specialized skills within months. The coordination of thousands of suppliers, the movement of massive prefabricated sections, the simultaneous operation of dozens of shipways, it violated everything German economic planning understood about industrial organization. But the German analysis contained a fatal assumption, that American industry would operate according to German principles of organization. The American system wasn't operating according to those principles. It was operating according to Henry Ford's principles of mass production, now scaled to dimensions Ford himself had never imagined. During the period of 1939 to 1945, 5,777 ships, including the Liberty ships, Victory ships, tankers, and military ships were constructed. The program employed 650,000 American workers at its peak. 18 American shipyards built 2,710 Liberty ships between 1941 and 1945, an average of 3 ships every 2 days. 3 ships every 2 days, not from a single yard, from the program as a whole. But the scale of that production, the coordination, the logistics, the sheer industrial momentum represented something genuinely new in human history. The Liberty ships themselves were simple vessels. Each could carry 10,800 deadweight tons. A single Liberty ship could carry 2,840 jeeps, 440 tanks, or 230 million rounds of rifle ammunition. They weren't glamorous. Their reciprocating steam engines, burning oil, produced only 2,500 horsepower and a maximum speed of 11 knots. German submarines could easily outrun them. German surface raiders could catch them with ease. But they could be built faster than Germany could sink them, and that changed everything. At the peak of the war, the US was delivering nearly 800,000 tons of ship per month, about 70 times as high as its average rate of merchant shipbuilding during the 1930s, 800,000 tons monthly. That wasn't 5 million tons monthly, as exaggerated claims might suggest, but it was still staggering. For a brief period, the US was responsible for nearly 90% of worldwide shipbuilding. The workforce transformation was equally remarkable. Before the war, shipbuilding was an exclusively male occupation requiring years of apprenticeship. To expand and diversify the production base, there was aggressive recruiting by both the Commission and the companies operating the shipyards. The need to reach out to new sources of labor for the emergency yards created opportunities for women to gain employment in the many trades needed to construct a ship. The symbolic figure of Rosie the Riveter partly emerged from these wartime shipyards. In the Gulf Coast shipyards, where labor shortages were most acute, African Americans had been excluded from the higher-paying industrial and manufacturing employment, but such a shortage of labor existed that reluctant employers had to accept that black labor was required to meet production goals. In the end, the record productivity for black labor in the Gulf shipyards was no lower than for any other group employed. American shipyard employment increased from 100,000 workers in 1939 to over 700,000 by July 1943. These weren't experienced shipbuilders. Most had never seen a ship under construction. They were farmers, clerks, housewives, students, Americans from every background, trained in weeks to perform specialized tasks that had previously required years of apprenticeship. The German intelligence assessment that landed on Admiral Land's desk in February 1943 reflected this fundamental disconnect. German economists, analyzing American production through the lens of German industrial organization, could see only impossibility. They calculated that American claims required more steel, more workers, more coordination than any economy could sustain. They were correct if America was organized like Germany. But America wasn't organized like Germany, and that difference would decide the Battle of the Atlantic. The spring of 1943 marked the turning point in the Battle of the Atlantic, though German Naval Command wouldn't fully recognize it for months. In May alone, 43 U-boats were lost. On the 24th, Karl Donitz decided to call his forces back. The withdrawal wasn't permanent. U-boats would return to the Atlantic, but their effectiveness would never recover. The mathematics that Donitz had relied upon since 1939 had reversed. Germany was losing submarines faster than they could build them. America was building ships faster than Germany could sink them. The numbers told the story with brutal clarity. By 1943, Allied countermeasures were beginning to take their toll. That year, 284 U-boats were sunk, in comparison to only 27 in 1940. Meanwhile, American shipyards were operating at peak efficiency. Production peaked in 1943, the year when the accumulated improvements in production techniques, workforce training, and supply chain coordination reached their maximum effectiveness. By the end of 1943, it took on average less than 50 days and around 500,000 labor hours to build a Liberty ship. In the most productive Kaiser shipyards, it approached 300,000 labor hours. The learning curve had been steep, but the results were staggering. What had taken 250 days and over 1 million labor hours in early 1942 now required 1/5 the time and less than half the labor. This improvement wasn't accidental. The Maritime Commission received more than 3,000 improvement suggestions during the war, which collectively saved $45 million and 31 million labor hours. Workers on the shipyard floor, engineers in the design offices, suppliers throughout the industrial chain all contributed incremental improvements that compounded into revolutionary efficiency gains. The German response to these production figures evolved through several stages. Initial disbelief gave way to attempts at rationalization. Perhaps the Americans were sacrificing quality for quantity. Perhaps these hastily built ships would prove unseaworthy in Atlantic storms. Perhaps the welded construction would fail under combat stress. These hopes weren't entirely unfounded. A major problem was discovered after 3 ships split in 2 while operating in cold water. 30% of the Liberty ship fleet eventually experienced the cracking problem. The issue was serious. 12 ships broke apart completely, including the SS John P. Gaines, which sank with the loss of 10 lives. Constance Tipper of Cambridge University demonstrated that the fractures did not start in the welds, but were due to the embrittlement of the steel used. The steel became brittle below certain temperatures, and the welded construction, which didn't allow cracks to be stopped by riveted joints, allowed fractures to propagate catastrophically. The problem was identified, analyzed, and corrected. Design modifications, improved steel specifications, and changes to welding practices solved the cracking issue in later production runs. The fact that American industry could identify and fix such a fundamental flaw while maintaining production schedules would have been impossible in traditional shipbuilding. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But the American system wasn't traditional. It was adaptive, iterative, and operating at a scale that allowed for rapid implementation of improvements across dozens of yards simultaneously. German Armaments Minister Albert Speer, who took control of war production in February 1942, recognized what was happening. In a 1944 memorandum to Adolf Hitler, Speer described the Second World War as a contest between two systems of organization. The conflict pitted Germany's system of overbred organization against the art of improvisation on the opposing side. Germany's outmoded, tradition-bound and arthritic organizational system manifested in exacting requirements and small numbers of high-end, technologically advanced systems. Speer understood the problem. German industry produced excellent equipment, well-engineered, precisely manufactured, built to exacting standards. A German U-boat was a marvel of engineering, far superior in many respects to American submarines. German tanks were often mechanically superior to their American counterparts. German small arms were precision instruments, but Germany couldn't produce them in sufficient quantities to match American mass production. The Liberty ship embodied this contrast. It wasn't an excellent ship by traditional standards. The reciprocating steam engine was obsolete technology. The design was basic, the accommodations were Spartan, but it worked. It could be built quickly, and there were thousands of them. Of the 3,000 Liberty ships produced, only 2 are still operational, and 4 more are preserved. Most were scrapped after the war, having served their purpose. They were never meant to last. They were meant to win. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German submarine campaign, despite its tactical successes, was ultimately fighting against industrial mathematics. Dönitz ordered his submarines into battle until 1945 to relieve the pressure on other branches of the Wehrmacht. 648 U-boats were lost, 429 with no survivors. Furthermore, of these, 215 were lost on their first patrol. Around 30,000 of the 40,000 men who served in U-boats perished. These losses were catastrophic. The U-boat force suffered casualty rates higher than almost any other military branch in the war. Yet they continued operations because Dönitz understood that releasing pressure on Allied shipping would allow even greater build-ups of American material in Britain. Preparing for the eventual invasion of Europe, the U-boats had to continue attacking, even as the mathematics turned inexorably against them. The full scope of American production extended beyond Liberty ships. The Liberty ship was effectively superseded by the Victory ship, a somewhat larger, materially faster, more modern-powered vessel of generally similar design. A total of 531 Victory ships were built between 1944 and 1946. The Victory ship represented the next iteration faster, with more modern propulsion, capable of keeping pace with convoy escorts. Where Liberty ships managed 11 knots, Victory ships could make 15 to 17 knots, fast enough to sail in high-speed convoys that German submarines struggled to intercept. The program also produced massive numbers of tankers, over 900 high-speed tankers by war's end. These vessels carried the fuel that kept Allied forces mobile, the aviation gasoline that powered strategic bombing campaigns, the diesel that ran military vehicles. Each tanker sunk represented a temporary setback. Each tanker built represented sustained operational capability. By late 1943, American merchant shipyards had achieved something unprecedented. American merchant shipyards built 4 ships for every pre-war ship they had. The fleet of Liberty, Victory, C-type and other vessels reached an all-time high of more than 3,500 dry cargo vessels, and more than 900 high-speed tankers. This huge fleet, in 1944, moved out of the United States more than 72% of 78,500,000 tons of cargo shipped. 78,500,000 tons. The scale is difficult to comprehend. This wasn't just military equipment. It was everything required to sustain Allied forces across multiple theaters: food, fuel, ammunition, vehicles, construction materials, medical supplies, replacement parts, personal equipment. The logistical challenge of moving this volume of material across oceans, maintaining supply lines spanning thousands of miles, keeping forces equipped and fed in Africa, Europe, and the Pacific. Simultaneously, it required shipping capacity on a scale never before achieved. The German economic assessment that had seemed so reasonable in early 1943 that American production claims were statistically impossible proved tragically wrong, not because the German analysts had made mathematical errors, but because they had fundamentally misunderstood what American industrial organization could achieve. Traditional European industrial development had occurred over centuries, through gradual accumulation of capital, slow development of specialized skills, careful expansion of infrastructure. German industry represented the pinnacle of this traditional development, highly organized, extremely capable, but bound by the constraints of that organizational model. American industry had developed differently. The frontier expansion, the vast continental resources, the necessity of rapid development across enormous distances, all had created an industrial culture that prioritized speed and improvisation over tradition and precision. Henry Kaiser's ignorance of traditional shipbuilding methods wasn't a weakness. It was liberation from centuries of accumulated assumptions about how ships had to be built. When Kaiser looked at ship construction, he saw an assembly problem. Prefabricate the components, move them to the assembly point, weld them together, train specialized workers to perform limited, repetitive tasks rather than waiting years to develop master craftsmen. Use the same management techniques that had built the Hoover Dam in 5 years, that had constructed the San Francisco-Oakland Bay Bridge in 3.5 years, that had created massive infrastructure projects on schedules that would have seemed impossible to traditional European engineers. The Maritime Commission's role was crucial. Rather than imposing rigid specifications and bureaucratic oversight, they encouraged competition between yards, shared innovations broadly, provided financing for rapid expansion, and got out of the way when production was running smoothly. The US firm of Gibbs & Cox modernized the British design and provided more detailed drawings to allow for novice workers to follow the construction plans. They were instrumental in the implementation of modular construction, centralized material and equipment procurement, and design for production features that became the foundation of cost-effective shipbuilding. The organizational innovation extended to logistics, coordinating thousands of suppliers, ensuring components arrived when needed, managing steel allocation, prioritizing transportation for critical materials. This required unprecedented levels of coordination across American industry. The fact that it worked at all was remarkable. The fact that it improved month after month throughout 1942 and 1943 approached the miraculous. German intelligence continued receiving reports on American production throughout 1943 and 1944. The numbers no longer seemed impossible because they could observe the results directly. Allied convoys were sailing with more ships. Losses to U-boat attack, while still significant, were being replaced faster than Germany could sink them. The material build-up in Britain for the eventual invasion of Europe was proceeding despite German submarine interdiction efforts. Dönitz noted in his memoirs that the relationship between ships sunk and ships built shows clearly what grave consequences ensued for the German war effort from the failure of our leadership to do everything possible to initiate a speedy and large U-boat building program even as late as the outbreak of war, and from our failure to use even such meager U-boat resources as we possessed exclusively to carry out their primary function, the destruction of enemy shipping. This was Dönitz's recognition of the fundamental miscalculation. Germany had entered a tonnage war, a war of production versus destruction, without sufficient resources to win that war. The elegant mathematics of submarine warfare that Dönitz had developed before the war assumed relatively stable production rates on both sides. It assumed that sinking a merchant ship faster than it could be replaced would eventually strangle Allied logistics. But American production wasn't stable. It was exponential, and no amount of submarine efficiency could overcome that exponential growth. The statistical impossibility that German economists had identified in early 1943 wasn't impossible. It was simply unprecedented. America hadn't violated the laws of economics or physics. America had demonstrated that industrial organization, applied with sufficient scale and ruthless efficiency, could achieve production rates that traditional analysis couldn't predict. By the time Allied forces landed in Normandy on June 6, 1944, the Battle of the Atlantic was essentially won. U-boats continued operating, continued sinking ships, continued dying in their submarines. But the outcome was no longer in doubt. American shipyards had built the bridge to Europe, one Liberty ship at a time, 3 ships every 2 days, 800,000 tons per month, until the accumulated tonnage became an unstoppable tide of material superiority. The German economists who had dismissed American production claims as propaganda weren't fools. They were experts applying rigorous analysis to available data. Their error was assuming that American industry would behave according to European industrial norms. It didn't, and that difference decided the war. The liberation of Europe began with a bridge built of welded steel. On June 6, 1944, when Allied forces stormed the beaches of Normandy, the invasion fleet included hundreds of vessels built in American shipyards that hadn't existed 4 years earlier. The troops, tanks, ammunition, fuel, food, and medical supplies that poured onto French soil represented the culmination of the greatest industrial mobilization in human history. German military planners, watching this armada approach their coastal defenses, were witnessing the physical manifestation of the statistical impossibility they had dismissed 18 months earlier. The scale of the D-Day logistics defied comprehension. Moving over 150,000 troops across the English Channel required thousands of vessels, landing, craft, transports, escort ships, supply vessels. Behind them, the sustained logistics of maintaining armies in Europe required constant resupply. The Liberty ships and Victory ships that had seemed so unglamorous, so basic, so mass-produced, now revealed their purpose. They weren't meant to be admired. They were meant to carry the weight of nations across oceans. According to William S. Knudsen, we won because we smothered the enemy in an avalanche of production, the like of which he had never seen, nor dreamed possible. This wasn't propaganda. It was accurate description. German forces in France, skilled and experienced, fought with tactical excellence, but they fought against an enemy that could replace every destroyed tank, every expended shell, every lost vehicle faster than Germany could destroy them. The mathematics of attrition had reversed completely. Albert Speer's analysis of the contest between organizational systems had been prophetic. By late 1944, almost the entire German economy was dedicated to military production. The result was a dramatic rise in military production, with an increase by 2 to 3 times of vital goods like tanks and aircraft, despite the intensifying Allied air campaign and the loss of territory and factories. Speer had achieved remarkable production increases through rationalization and ruthless efficiency. German tank production doubled between 1942 and 1944. Aircraft production increased substantially, despite Allied bombing. This represented genuine organizational achievement under devastating circumstances. But it wasn't enough. With the exception of ammunition for the army, the increase in production was insufficient to match the Allies in any category of production. Germany was producing more than ever before, yet falling further behind each month. American industry wasn't just producing at higher levels, it was accelerating. The learning curves continued improving, the supply chains grew more efficient, the coordination became more sophisticated. The Victory ship program exemplified this acceleration. Where Liberty ships had represented speed and simplicity, Victory ships incorporated lessons learned from 3 years of emergency production. They were faster, more modern, more capable, yet they were built using the same mass production techniques that had made Liberty ships possible. The program demonstrated that American industrial methods could scale upward in sophistication while maintaining production speed. The human cost of the U-boat campaign had become unsustainable for Germany. Both of Dönitz's sons were killed in action during the Second World War. Peter was killed on May 19, 1943, when Unien 54 was sunk in the North Atlantic with all hands. Klaus was killed on May 13, 1944, aboard E-boat Sohn 41. These weren't just statistics for Dönitz. They were personal losses that reflected the broader catastrophe consuming the U-boat force. 75% casualties, entire crews lost on first patrols, submarines that sailed from port and simply disappeared, their fates unknown until after the war when records could be compared. The Allied advantages that finally defeated the U-boats were multiple and interconnected. Breaking the Enigma code allowed convoy routing that avoided wolf packs. Long-range aircraft closed the mid-Atlantic gap, where U-boats had operated freely. Improved radar and sonar made submarine detection more reliable. Escort carriers brought air power directly to convoy protection. New weapons like Hedgehog and Squid increased the lethality of anti-submarine attacks. But underlying all these tactical and technological advantages was the fundamental reality of production capacity. Even if every advantage had been stripped away, even if German submarines had continued operating with impunity, they couldn't sink ships faster than American yards could build them. The tonnage war was lost not on the ocean but in the shipyards of Richmond, Portland, Baltimore, and dozens of other cities where welders worked around the clock on prefabricated hull sections. The final production statistics told the complete story. The 2,708 Liberty ships that were built collectively generated the capacity to transport 29,246,400 tons of weapons, food and supplies to European and Asian military theaters that helped win World War II. Add the Victory ships, the tankers, the specialized vessels, and American emergency shipbuilding produced vessels capable of transporting well over 40 million tons of cargo. 40 million tons. That number represented not just shipping capacity but transformed possibility. It meant armies could be supplied anywhere in the world. It meant strategic bombing campaigns could continue despite aircraft losses, because replacement bombers could be shipped to European bases. It meant the island-hopping campaign across the Pacific could advance because each seized island could be supplied and reinforced. It meant the siege warfare of attrition became warfare of abundance. German economists after the war, analyzing what had happened, struggled to reconcile their pre-war assessments with observed reality. They hadn't been wrong about the mathematics within their analytical framework. They had been wrong about the framework itself. American industrial organization operated according to different principles than European industry, and those principles, when applied with sufficient scale and determination, achieved results that traditional analysis couldn't predict. The workforce transformation represented one of the war's most significant social changes. The employment spike was in relation to the tremendous amount of war production which the US was undertaking. Gulf Shipbuilding obtained 240 employees at the beginning of 1940 and increased to 11,600 employees in 1943. Alabama Dry Dock raised numbers from 1,000 workers to 30,000 in the most productive years of the war. These workers weren't just building ships, they were building the foundation for post-war American economic dominance. The shipyard experience trained hundreds of thousands of Americans in industrial skills, management techniques, and organizational methods that would reshape the post-war economy. Women who had never worked outside the home became skilled welders and crane operators. African Americans excluded from industrial employment before the war gained skills and experience that would all support the post-war civil rights movement's economic demands. The integration of millions into industrial production created social changes that extended far beyond the immediate war effort. The economic impact rippled through American society. Demographics of employment consisted of 8 million women, including African Americans and Latinas, adding to the 24 million that searched for defensive jobs outside of the war. This massive employment surge pulled America completely out of the Great Depression that had paralyzed the economy throughout the 1930s. The unemployment that had stood at over 17% in 1939 vanished. Labour shortages replaced joblessness. Wages increased. Consumer savings grew as wartime production consumed available goods. The industrial infrastructure, built for emergency shipbuilding, didn't simply disappear after the war. The facilities, the trained workforce, the supply chains, the organizational knowledge, all became foundations for post-war American industrial dominance. The techniques developed for mass-producing ships adapted to peacetime production of automobiles, appliances, construction materials. The management methods pioneered by Kaiser and others spread throughout American industry. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The German miscalculation about American production capacity ultimately stemmed from a fundamental misunderstanding of what America represented as an industrial power. European nations had developed their industries over centuries, constrained by limited territories, established social structures, traditional methods. American industry had developed in decades, across a continent, with constant pressure to innovate and improvise. The frontier experience, the massive infrastructure projects of the Depression era, the cultural emphasis on practical problem-solving over traditional methods, all created an industrial culture uniquely capable of rapid transformation. When German economists calculated that American production claims were statistically impossible, they were correct within the constraints of European industrial norms. But American industry wasn't constrained by those norms. It operated according to different principles, at different scales, with different assumptions about what was possible. The statistical models that accurately predicted European production capacity failed completely when applied to American industrial organization. The irony is that German intelligence had access to accurate information about American production. The reports weren't fabricated. The photographs of shipyards weren't propaganda. The production statistics weren't falsified. But the numbers were so far outside German experience that they seemed unbelievable. The human tendency to reject data that contradicts fundamental assumptions proved stronger than the evidence itself. This cognitive failure extended beyond shipbuilding. German assessments consistently underestimated American industrial capacity across multiple sectors: tank production, aircraft manufacturing, ammunition output. American achievements in all these areas exceeded German predictions. The pattern repeated. Initial disbelief, gradual recognition, final acknowledgement when the material reality became undeniable on the battlefield. The Battle of the Atlantic, which Churchill later called the only campaign that truly frightened him during the war, was ultimately won not by naval tactics or technological advantage, but by industrial capacity. The U-boats were never defeated in the traditional military sense. They were overwhelmed by production capacity that rendered their tactical successes strategically irrelevant. Dönitz recognized this reality even before the war ended. Despite the German losses, Hitler continued to have the fullest confidence in his commander of the Kriegsmarine. But confidence couldn't change mathematics. Submarines continued sailing, crews continued dying, ships continued sinking. Yet the ratio of ships sunk to ships built had reversed so completely that German submarines were fighting not to win, but simply to delay the inevitable. The legacy of the emergency shipbuilding program extended far beyond the immediate war victory. It demonstrated that industrial capacity, properly organized and sufficiently motivated, could achieve results that seemed impossible by conventional analysis. It showed that traditional methods and established practices could be discarded when necessity demanded innovation. It proved that workforce training, supply chain coordination, and mass production techniques could scale to dimensions previously unimaginable. Modern analysts studying the program have drawn parallels to contemporary challenges. The rapid development of production capacity under wartime pressure offers lessons for emergency mobilization, crisis response, and large-scale industrial transformation. The ability to train hundreds of thousands of workers in weeks, to build entirely new facilities in months, to coordinate complex supply chains across continental distances. These achievements suggest possibilities for rapid industrial transformation when circumstances demand it. But the program also revealed costs and limitations. The push for speed meant some ships were poorly built. During World War II, there were nearly 1,500 instances of significant brittle fractures. Working conditions in the shipyards were often dangerous, with injury rates far exceeding peacetime industrial standards. The environmental impact of such rapid, large-scale industrial activity wasn't considered. The program succeeded because it had a clear, urgent goal and near unlimited resources, conditions rarely present in peacetime. The German economists who calculated that American production was statistically impossible weren't incompetent. They were experts applying rigorous analysis to the best available data. Their failure was one of imagination, not mathematics. They couldn't imagine an industrial system organized so differently from their own experience. They couldn't envision production methods that discarded centuries of tradition in favor of improvisation and speed. They couldn't conceive of an economy that could transform itself so completely in response to national crisis. The morning of May 8, 1945, Germany surrendered unconditionally. The war in Europe ended. In shipyards across America, workers completed final vessels. Then began the process of demobilization. The emergency was over. The impossible had been achieved. American shipyards had built the bridge to victory, one welded hull at a time, proving that what seems statistically impossible by conventional analysis can become inevitably real when human ingenuity, industrial organization, and national determination align. The lesson wasn't that statistics lie or that economic analysis fails. The lesson was that human systems can transform in ways that exceed the predictive power of models based on historical precedent. America didn't violate the laws of economics. America demonstrated that those laws operate very differently when applied to systems organized according to fundamentally different principles. The German calculation was correct within its assumptions, but the assumptions were wrong. And in war, as in economics, assumptions matter more than calculations. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.